Hello, everyone. All right, so is there anything in particular that you guys would like me to address tonight? So just adding items to an array, Matthew? Okay. So are you thinking of the week 10 homework, the string bag? Is that what you're thinking of with regards to that? Okay. So when I think of the string bag, I don't know if you guys have ever like watched The Price is Right. I'm not a big Drew Carey kind of a fan, but way back in the day when Bob Barker was in charge of The Price is Right, he would have a game where he would have a bag, and inside of the bag would be like different numbers, and people would have to reach their name in to pull out a number and then try to determine if the number belonged to the car or the coffee pot or whatever else he had in there. I don't know if any of you guys ever watched anything like that, but that's what I comes to mind when I think of this string bag. Okay, so the whole point of the string bag class, so this is your week 10 homework. It's like I've got it wrong. Or week 9 homework, I'm sorry, week 9 homework is this string bag class. Okay, so let's see, it starts right here. So it's going to hold string objects. Okay, so you're going to have an array that holds string objects, and they actually define the beginning part of the array for you there, but notice there's no equal sign. So this is a partial definition. It's not completed, and then the point is in your constructor that you'll finish the definition of the string bag object. Okay, so it's partial definition. You cannot access this or reference it at this point until you finish your definition in the constructor. And actually they do that for you right here. So then they've got this count variable that's going to keep track of how many strings have been added into the bag. Okay, and then they give you the constructor here that has one explicit parameter, which is the length. Okay, so we've got that, and then they create the rest of your instance variable. They're defining it with the size of whatever the length is, and then they set your count equal to 0, meaning no items have been added to the string bag yet. Okay, so we know how to create objects for this. So if we're going to test this, so the first one is testing write a function that returns the number of elements currently held in the string bag. Okay, and so if we look right here, if we read this also, we have a comment, right? If we read that, it says the number of elements being held in our string bag, right? And also the next index where a new string can be put. So it's telling us right there that our count variable should tell us how many elements are currently held. So let's say I create so if I'm going to test this, you have to create your object, right? So we know how to create an object. Remember, the object, we're calling the constructor only, and this is our constructor right here, right? So we don't care that this is an array. We don't care about any of that stuff. We're testing this, and all we know when we're testing it is this constructor, and then I'm testing it for how many elements have been added. Let me pull up where did my Notepad++? Okay, so to test it, it's the name of my class, which is string bag, right? So when we're testing, remember, testing is always the thing. Create your object, do any setup work, right? Call the method you're testing, make sure it worked. Okay, so every single time, that's what you're doing. Yeah, Dylan, that's exactly our only option. So for this first one, all we know about at this point is the constructor. So it's a string bag is the name of our class, which is also the name of our constructor. So you can call this whatever you want, temp bag, whatever you want to call it, equals new string bag. And then we're going to give it a length. How many strings or sentences or words or phrases or whatever you want to think of when you're analyzing this do you want to create? So I'm going to go with 10. So that means the maximum number of strings that I can add to this bag or words that I can add to this bag is 10. But how many have I added at this point in time? 0, right? 0. So at this point, I can do an assert equals 0 temp bag dot and whatever this is called. Size. So down here they tell you it's going to return, its integer is what it's returning, and it's called size. Because that's how many I've added at this point. I haven't added any, oh, sorry. Forgot my closing parenthesis. I haven't added anything at this point in time, so my bag has to be empty, so my size is going to be 0. So it's really tempting to say that what you're returning is 10, but that's not what this is asking. Return the number of elements currently held in the string bag. So it's not asking you how many elements could be held, which would be 10. It's asking you how many are actually there. And because we haven't added anything at this point, there are no elements there, right? Okay. And remember, this count variable is supposed to tell you how many elements there are. So I'm not going to go over that. I'm just going to go over your test cases. All right. So now we're inserting a string into the bag. If there's space, we're going to input into the bag, right? And we're going to return true if there was space. If there's not space, we're going to return false. So here's our Boolean add, and we give it a string value, right? So if we're going to test this again, create your object. So again, I'm going to go with 10, and then I'm going to add. So temp bag dot add, and I'm going to add it. Well, I need to check. This is either going to return to me a value of true or false. So I'm going to assume that this first one is going to return to me true. Temp bag dot add, and I'm going to give it a string of 1 or whatever, any string you want to do. So I'm going to assume that that's going to give me a value of true, or of true if this successfully added, and it's the first one I'm adding to my list. What else can I test here based upon what I know at this point in time? There's one other test I could do just to verify that things are working the way that they should. I can definitely try to test for the false, and I need to do that. But one other test I could do just right here is I could also test my count, right? Or my size, because now my size should be 1. I just added 1 item to it, so now my size should be 1 if it's working correctly. Okay, but I definitely want to test it enough to get to the false. So maybe instead of going 10, I'll go 3 because that's pretty ambitious. And I will just do this 4 times. Oh, temp size. That does not have a 0 in that. Sorry, guys. No explicit parameters for the size parameter. All right, so this is 1, and then I would be 2, and then I would be 3, and this should still be 3 because it should not add it, and I should actually get a false this time. So I could change my string values to 2 and 3 and then 4. Okay, right? So because it tells me as long as there's room, I only have room for 3 strings. So string 1, 2, and 3 is what I'm got room for, right? So it should return true when it adds 1 and bump my count up by 1. It should return true when I add 2 and bump my count up to 2. 3, it should return true and bump my count up to 3. But now I'm up to 4. So yes, the add. I'm testing the add. Well, yeah, you can kind of test. Yeah, really, you are. Theoretically, if we had given you everything all at the same time, you would want to do the adds when you're testing the size just to make sure. But yeah, so this is really a better way to test the size here. And then this last one would be over the limit. Okay, so do you see what I'm doing? I'm only worried about one string at a time. I'm in my test cases, I'm not doing anything with the array because the array is irrelevant to me. The array is only inside of the class. Well, you could definitely do a loop. So what you can do here is you can say for integer I equals 0, I is less than 3, oh, sorry, equals 1, I is less than 3, 0, 0. I is less than 3, I plus plus. So we could definitely do that. But we need to add string value. You could add the same string value to this. It doesn't really matter. But you'll want to do an assert true temp bag dot add something. It doesn't really matter if it's all exactly the same thing, right? So we can do that, and you can also do an assert equals I plus 1 temp bag dot size, right? So if I is equal to 0 when we add something, then we would expect it to be 1 and so on. So we could definitely do that. And then, but then after your for loop, you want to add one more. And so you're going to do an assert false temp bag dot add too much. And then the assert equals 3 temp bag dot size. Okay, so you want to, you can definitely do this to add, well, this is I is less than 3. You know what I mean? So you can definitely do this. It doesn't matter that we're adding the exact same thing, you know what I mean? So we can do this, or you could even do something, you know, and then concatenate it plus I. So it would be something 0, something 1, and then something 2, and so on. Yeah, see, that's your problem. In the test case, all we have are our methods. You don't have direct access to the bag, the array list, or the array, right? All you have access to are your methods. So all you can do is your methods here. The only place you have access to your array is inside of here. But the problem is inside of here, you're only dealing with one thing at a time, one string at a time. Here, again, we're only dealing with one string, so we call our add and add that one string. But here, we don't have access to the array. You only have access to the methods. Think black box. You can't see inside of that class. You only know the outside point of your what your methods give you. Okay? So index of, so this one is going to give us the element position of a string in the bag, and then it's going to return that actual number if it's found, or a -1 if it's not found. So you need to do a little bit of work. Again, create your object, right? Add something to the bag, you know, so we could add something, temp bag dot add something, right? And then you need to check to see, so you're going to do an assert equals, and this should be position 0 because it's the very first one you've added. So okay, well, since it's the very first one I've added, it should be position 0. So yeah, so you're looking at the actual physical position. So it'll be position 0 in the index 0. And then, what is it, temp bag dot index of, and I would be looking for the string something. Okay, so I'm actually, it would give me 0. But then I'm going to do a something else, assert equals -1, temp bag dot index of, not there, or whatever, you know, a string that you did not add. Okay, so I can make sure it works if it is found, and it works if it's not found. Contains, this is just returning you a true or a false value, right? It's going to return true if it finds it and false if it doesn't find it. Well, you just did a bunch of work. I'm sorry. So you're going to do basically the same thing we just did here, right? The test case is exactly the same, except for insert equals, you're going to do an assert true, calling your method, and insert false, right? Okay, are you seeing where we're going? Like when we're testing it, you're only dealing with what you've got. You know, you don't have access to the array, so you can't touch that array from your test cases. Are you guys following along on this? Yep, definitely don't do that. Because, you know, nowhere, if we look at these methods, nowhere is there an explicit parameter that's the bag, that's an array, right? None of these methods have an explicit parameter that's an array. Well, I mean, I understand. So as far as the reverse goes, you know, so what you have to kind of do is like put this stuff out on paper. Okay, so when you're removing a string, you're going to remove it and then you're going to move everything over by one, right? Overwriting it with the element of the last position. So what you have to kind of do is you have to kind of create a string bag. So let's say, all right, I'm going to do a bag and I'm going to have, you know, a potential of however many elements in this, right? So 6 elements of this. And let's say I'm going to, so I also have my count variable, right? And my count variable initially equals 0. So it's kind of like work through this by hand, what it's going to look like. So let's say I add a string in here and I have room. So my size of my, or not my size, because the size is how many elements have been populated. So right now my size is 0. My count variable contains a value of 0. But now I add something to my bag. So here I add to my bag Fred, or I don't know, let's call it yellow. Okay, so now at this point I've added something, so now my count is going to equal 1 because I've added something to the array, and notice I've added something to it, so I have 1 element in my array, and my next empty position is 1. So this count variable serves 2 purposes. I've added something to the array, and my next empty position is 1. And then I add something here, so I add blue as my next one. So now my count equals 2. And again, I have 2 of my element positions are populated, and my next empty position is 2. So that count serves something. So I'm just going to add one more item to this, and this is going to be green. And my count will be 3. Okay, so I have 3 elements populated in my array, and my next empty position is element position 3. So I have 3 elements populated, 0, 1, and 2. The maximum that could be added would be 6 items, which would populate 0 through 5. And you could populate this whole thing if you wanted to, but we don't have to do that for this case. You know what I mean? So then if I wanted to test like my index sub, I could test for a yellow and it should give me a 0, and I could test for blue and it should give me a 1. I could test for green and it should give me a 2, and then I could test for red, but red doesn't exist, so it should give me a -1. And the same for your contains. This shouldn't actually be index of, it should be contains. The same for your contains is, you know, it should return true if it's there and false if it's not. So with yellow I should get a true, blue I should get a true, green I should get a true, but red or orange or purple, I should get a false because it doesn't exist in there. All right, so remove says it removes, let's see, this one is contains. Remove says if it finds it, then it overwrites it with the element at the last position. So what it's going to do, so this is not the last position. This is the last position, right? So if I tell you I want you to remove the element, so the remove takes in a string. So if I tell you I want you to remove blue, then what's going to need to happen is blue now becomes green, right? The count, this gets erased, so this becomes a null value. You set it equal to null. My count gets deducted, -1 now equals 2 because I've emptied it out. And so now my blue is no longer there because I said remove it. It gets replaced with what is in the last field. Okay? Do you guys follow that? It'd be easier if I had a whiteboard and I could cross things out for you guys. But yeah, so that's what you're doing on the remove function. The toString is going to do them comma separated. So if we were back to having our green in here. All right, so let's go back to having our green. So I actually have something. So you want it to be, you have to be careful on this one. Your output here should be yellow, blue, green, right? It should not be yellow, blue, green. Okay, so it should not have that extra comma in there. It should be just yellow, blue, green. And it should definitely not be comma, yellow, blue, green. Okay, so you just have to be careful. So you'll test that, you know, if I've got these things added in there, then I'll call my toString. The output is a string value, so this is what I would expect it to be equal if it were to correctly move. And then reverse, I'm reversing them in there, but I'm not reversing. I'm not going to put space, 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 green, blue, yellow. I'm only reversing the ones that are populated. So if this is what I have initially, then what I should end up with is 0 is green, 1 is blue, and 2 is yellow. Okay, so I'm not sorting them, I'm just reversing their order. And then my 3, 4, and 5 will still be blank. Now, it's easy enough to do this because we have a count, right? You have your count variable. This tells you how many elements exist in your array, and it tells you your next empty position. So if I'm going to loop through, let's say I want to loop through everything in my array, then it's for integer I equals 0, starting lower boundary of my array, I is less than the count, I plus plus. Okay, so not I is less than my bag dot length, right? Not that, because that will get you to these empty guys. And you don't want to do stuff with these empty guys. You just want to worry about the ones that have been populated. So if you're going to loop through your array, not in your test cases, only in the bag class, right? You always want to say I is less than your count. So that lets you only populate the elements that actually contain values. Did this help out? Did this help out explain a little bit about this particular class here? Any other questions about this? Number 4. Okay, well, I just gave you the answer to that. So what are you going to do to avoid getting to the nulls? Use the count, exactly. Yep, That is exactly what you're going to do, because if you're doing this, I'm never accessing the empty guys at the end. I'm only accessing the data that's been populated. All right, you guys ready to, oh, go ahead. It says it's likely that you wrote the above code so that if you try to store a null string in the bag, something will crash with a null pointer exception at some point. So how you would get the null pointer exception is, well, so we're doing strings, right? So if I'm in here, so let's say I did less than this dot bag dot length, okay? And but this is the index of function. Okay, so if I'm in here in the index of function, if I say if this dot bag sub I, it's string data. How do we compare string data? Equals, right? Dot equals, and then we have our whatever input, whatever your explicit parameter is, param goes here. If this dot bag dot equals this, then we would return I, right? Well, the problem is if this is a null value, if the array contains a null value, you're going to get a null pointer exception because you cannot call a dot equals method. Yep, that's what the question is asking. Yep. You cannot call a dot equals method on a null value. Yep. Everybody is, Matthew. I've got this one program at work that's just driving me nuts. Every day I come in, it's telling me about this DB null value, and I have tried checking every which way I can to eliminate that. And it's a struggle for me. I am checking left and right and left and right, and the code crashes every morning. But if I ran it manually, it works fine. So it's a challenge. Yes, so the code, if you're using less than this dot count, then you'll never get to those null pointer exemptions because you'll never be accessing a null value in your array. You'll only be accessing the array elements that actually contain values. I mean, another option I guess you could have in here is you could say, if this dot bag sub I is not equal to none, and then you could go in here and do all this sort of stuff too. But it's easier to start here. Oh yeah, absolutely. So we have the question, is it okay to put a return statement before the code into the code? I do it all the time. I mean, if I know, that I've already, well, I mean, assuming it's appropriate, but yeah, you could say in here, you could have said if this equals none, then I know I've gotten to the end, so let's just return, -1 or whatever it is, so you could All right, guys, sorry about that. I have been having trouble with my internet tonight. Yeah, it's dropped like twice on me so far tonight, but yeah. So, as I told my previous class, I am not sure that Spectrum Digital is better than Time Warner Analog because I never really had these problems with Time Warner Analog. So, anyway, all right, so let me jump into Lab 4. And if I get disconnected, I will try to get back as soon as I can. All right. So the Lab 4 scenario, unfortunately, we are still dealing with golf. All right, so we're just going to still deal with golf. So we did the player and the whole classes, okay, and now the person that you were supposed to be working on this project with, they are not able to complete their portion of the work, so now you're going to have to do their work as well, okay? So again, here's how it's laid out. The player is dependent upon both the scorecard and the course. The scorecard is dependent on the course, and the course is dependent upon the whole class. Okay. So John is going to work on the course class. You're going to work on the scorecard class. Okay. So we're going to have an instance of player for each player in the tournament, and an instance of each player will contain a reference to a single instance of the scorecard class. So we did that last time where we created a scorecard inside of the player class, right? One player of instance, one player of scorecard, so it's a one-to-one relationship. Okay, so the scorecard focuses solely on the information needed to drive the scoreboard display. Okay, so here's how it's going to look, and notice that looks like an array right there with the little square brackets going on, so 0 up to a maximum of 18 holes or however many holes are on the golf course. So it keeps track of multiple holes, so you're going to use an array, not an array list. Lab 5 will take you to an array list, all right? But right now we're just using an array to represent the golfer's score. Okay, so you're going to, here he gives you the whiteboard, the score on hole 1, score on hole 2, and notice hole 1 is in element position 0, score 2 is in element position 1, and so on. Yes. How many holes should you plan for? You have your constant num of holes in the course class that's going to tell you the maximum size of your array. Normally it's 18, but it could be lower, like it could be a 9-hole golf course, or maybe it's a special tournament, so you're not going to hard code in the value 18. You're going to go to that constant course.num of holes, just like we did with other course methods in Lab 3. Okay. We are going to have these instance variable, or what we have a constructor here. So the constructor that takes in the name, which was the player name, right? When we called it from the player class and we created our scorecard object, we passed in the name of the player. Okay. Get name is going to return the name of the golfer. So we aren't going to have a set name because it's the scorecard. There's only the one constructor. We're not going to have an empty or default constructor. We only have an explicit constructor that takes in the name of the player, but we do have a get name that's going to return it. We have the record score that's going to record the score on the hole and return true if the recording is successful. So there's some ways that you may not be able to record the score, in which case you would return false. Get the score on the hole, so you're going to return their score, however many strokes it took them to complete the hole, right? The holes played, so the number of holes, which would be the number of scores that you've entered, okay? The count category, so there will be some categories, which I assume we're going to find down here further. Compute strokes, the total number of strokes, so you'd add up all the strokes through the given hole. Compute versus par, so we're back to that nasty calculation from Lab 1 or Lab 2. formatting the item, so these, and format scores in the toString. So this puts everything out in a nice, pretty scoreboard type format. Okay. The workhorse is our record score. So this is the key. This is what's doing all the work. So it has two parameters coming in, the hole number and the player's score, the number of strokes it took them to finish the hole. But the holes have to be recorded in sequence. So it has to be 1 and then 2 and then 3 and then 4. So you can't do 1 and then 4. So that would be, if it's out of sequence, that would be a circumstance where you return false. Or if the hole is, you're trying to record a hole that's not even on the course, right? That's greater than your number of holes. That would also be an instance where you return false. Okay. There's 3 categories: under par, par, and over par. So when you're returning how many holes are in a given category, it will tell me how many holes did the person score par on. And you would compute that up, and how many were under par and how many were over par. So that's definitely going to be a loop as you process through these. The categories are going to be integer values, so how do I know which one is which? You get to decide what you want. So you're going to have you're going to have constants, under par, par, and over par. He said it doesn't make any difference what values they are as long as they're distinct, but probably you'll just go, like maybe under par is a -1, par is a 0, and over par is a 1, or whatever you want. In the test cases, the instructor test cases are going to refer to your constants. So your constants have to be named this: under underscore par, par, and over underscore par, right? So you have to name your constants that. What values you assign, it doesn't matter. Compute strokes, compute versus par, take in a whole number as a parameter. So you have to total up the golfer's scores on all the holes up to the however many holes they've completed. Okay, so it's taking in one explicit parameters like compute strokes 5, and it will total up from holes 1 through 5. Okay, if you give it a 2, you're only going to add the first 2 holes together, and so on. Compute versus par works the same way. You're only going to add a par through whatever hole number they give you. Okay, and this is how the output should look when you call the toString. So here's your whole number at the top with the total, a dashy line here, and then below the player name, what they are overall versus par, and then what they scored on each hole and their total number of strokes here. Okay, so here's just some more information on the different and what they would return. So these guys, if they try to get the score on a hole, compute strokes versus par, but the hole number that they gave was not one of the holes that had actually been played, you're going to return invalid entry. So this is also a constant called invalid entry. And again, here you're going to get one of these categories, but if the category is not one that they played, then you're going to also return invalid. So if it's not your under par, par, or over par, you'll return invalid entry again. Okay, so how do you find par for a hole? You're going to call the static method, and remember static means it belongs to the class. So you'll do a course.getHole, passing it the hole number 3, okay? And then once you have that hole, that'll give you an instance of a hole object. Once you have that, then you can call the getPar method of that hole to get the par for 3, and then you can check it. So basically, you can do course.getHole sub3.getPar. You can string all that together if you want to. Might be a little confusing there, but we got it. And again, here's all the standard stuff that comes down here. Okay, now, with this, again, since you're only modifying the scorecard class, the other ones are there. You can certainly, well, you can see here we didn't even give them to you, did we? We just gave you the scorecard class. But you still have access to the course the hole and the player class because this is the folder. Let me go back up here. So here's our Lab 4 folder. If you double click on that, you've got this plus libs here. You double click on it, you've got jar files, the course.jar and the whole.jar right here. So you've got the executables that the scorecard needs access to. And if we double click on the doc, in here then is your course Java docs, and let me go back again, your whole Java docs. So I recommend that you go right to that plus libs folder, the docs, and immediately open up your Java docs so that you know what you've got available to you. Like here it tells you num of holes, add hole, get hole. You're not going to be really interested in that, but you are interested, well, you're interested in the get hole, okay, and you're interested in the num of holes. Constant. So those are the two things you're predominantly going to be using in the course. And then when we're in the whole class, we're not going to be really creating a whole object here, but we do want to know par. So this is the value we're going to be using this time, get par. Okay, so that'll tell us par of the whole class. Okay, so let's open this baby up and take a look at it. All right, so we've got our test class and we've got our class itself. So up here, under par, they set that to -1. So you're going to want to define your constants. So under par, par, and over par. And so, like I said, it may be easiest to just go -1, 0, and 1. But whatever values you want, it doesn't matter. You get to pick. Okay. So you'll create your constants. The constant names do have to match. So it does have to be this under par like that and par and over par. So you do have to do that. And here's your constant for invalid entry, and it's assigned a value of -999. Okay. We have our name, which is going to be the name of the player. You've got your array that you're storing the scores in. And notice it's only initialized here. You've just said, give me, I'm going to call it scores, set me aside a location in memory, but right now it contains null value. It does not contain any, it's not usable at this point because we don't have an equal sign to finish the array definition. And then we have this holes played. You notice it says this is a tracking variable. It's similar to that count variable from the string bag. Okay. It's going to not only tell you how many holes have been played, how many entries we have in the array, it also tells you the next empty position in the array. Okay, so if you've played 0 holes, there's 0 items added to the array, and the next empty position is element position 0. If you've played 1 hole, there's been 1 score added to the array, and that's in position 0, right? Element position 0, and the next empty position is element position 1. Okay, so it serves two purposes. It tells you how many you've added and what your next empty position is. Okay, so that's your setup stuff. So we're going to come over here. We've done some work over here. They've got a scorecard 2. They've created a golf course here, just 6 holes for testing purposes, but that could be anything in the instructor version. So just because your test case only has 6 holes, doesn't mean you can assume 6 holes, all right? You're always going to use the course.num of holes parameter to determine what's the maximum number of holes that you can record a score for, okay? And then they've actually created a scorecard here, but they've only recorded 4 scores in this particular one. Okay, so testing the constructor, they've actually done the work for you, creating a scorecard with for Nicholas, asserted that it was not equal to null. They've retrieved the name, retrieved the number of holes that have been played, which is 0 at this point. So this tests the constructor. Okay, score on the hole. So they've created their scorecard again, recorded 1 score, hole number 1, strokes 5, okay? And so then you need to test that out. So test for proper hole reference. which one are we testing here? Get score on whole. So this is actually testing the get score on whole. So it could be that we've recorded one score, right? So this is on whole number 1. So they're testing the invalid whole. So they've given it a whole of -1. So they're testing, remember we said it's important to test the boundaries, right? So they're testing below the lower boundary because your lower boundary is 0. So get the score on the whole -1. And of course, -1 was not played. It's not a valid score, so it should give us invalid entry. 0 was not played either. The whole number that's been played is whole number 1. So that gives us an invalid entry. And then they get the score on the number of holes plus 1. So they test the upper boundary. And that gives us an invalid entry, but you need to test for this valid entry that you just did. So you're going to do get score on hole 1, and you would expect it to return you a value of 5, right? So that still needs to be written in here. Good testing on all the invalids, but they're missing the testing for the valid. Okay, recording strokes. So this one, again, will create our object here, and then we're going to record hole number 1 and true, and get how many holes have been played now? 1, right? And so now you're going to need to test below to see was the right score recorded, so you'll get the score on that particular hole, and you would expect it to have a value of 5 because that was correct. And then you need to test, this is testing maxing out the array, and then you'll add 1 more, but you also want to add 1 out of order. So we've added 1. I would say add hole number 5 now and make sure it doesn't work. So that's what this is, test for something out of sequence. So something other than 2, make sure it doesn't work, make sure it returns a false and it doesn't change the number of holes played. And then here we're maxing out our array, and then you'll add 1 more at the bottom and make sure it doesn't get added as well. Okay, compute strokes. So if we add, oh, now they're using the card 2. Okay, so they're using that card 2 up at the top. So you can manually say, all right, if I say hole 1, it should return a 4. If I say 2, it should return 10. If I say 3, it should return 13. If I say 4, it should return 15. And if I say 5, it should give me invalid entry because I didn't play hole 5, right? So that's what you're going to, so that's kind of what it's doing down here. So compute strokes 1 is a 4. So if 2, what would you expect? 3, what would you expect? 4, what would you expect? 5, and 6. Compute versus par is going to look exactly like this, except for you're calling the compute versus par. And then you're going to need to figure out those values. Count category. So you're going to need to, so it's saying that there are two that were under par. You're going to need to, once you figured out par, take a look at the strokes, determine how many of those holes were over par, under par, whatever, and then set your test cases for each one. But then you also need to pass it something that's not valid. And how do you do that? Easy enough. So just give it some value, 72. Like whatever. We know that you set up these constants, right? 1 is -1, and then whatever you chose. So just pick some value that was not whatever you chose. Give it a 72, and it should return invalid entry. For whatever value is not there. Scorecard. Well, I mean, we know what the scorecard's supposed to look like. So this is a format of an item. So this format's a specific item versus this format's the whole thing. So you can kind of figure this out. Take advantage of that driver program to see what the output should look like, because that code is provided for you. Thank goodness. Okay, so that's a rundown over there. 12 minutes left. Let's take a rundown of the class. Okay. We have our constructor here. We have one instance Oh, sorry. Not sure. Did we make it through the test class? No, I did. But apparently you guys did not make it through the test class with me. Whereabouts where did it all stop? It died when I started working on the test class, or, oh man. Oh, good. Thank goodness. I thought, oh my goodness, if I have to read the whole test class. Okay, so for the constructor, you're given one explicit parameter, but you have to initialize all three instance variables, right? So the player name, you know what that one is. But as far as the array goes, it's really important. This dot scores equals, and then you're going to reference that course.num of holes to define the size of your array. Okay, don't make the mistake of hard coding that value in, because it could be anything. In your test class, you're using a value, the six holes, but the instructor's class may be using 9 or 10 or more. Okay, so use the constant from the course.num of holes. And again, you know what that is because you can come out here to the course and look at the num of holes constant right there. Okay. You also need to initialize the number of holes. At this point, how many holes have been played? So how many holes have been played at this point when you're just creating the scorecard? Are you guys still there? Okay. So I've just handed you a scorecard, but you haven't even stepped on the course yet. How many holes have you played? Yeah, 0. So you're going to initialize this to 0. All right, recording a score. First, you have to make sure the hole is valid. So don't even think about it being in sequence. First, just check and see if it's valid. So how do we know a hole is valid? What's the valid range for our hole? Well, it's not going to be 0 to 18, right? Because, you can't, there is no hole 0. So 1, but are you going to use 18 or are you going to use your constant? Because this might just be a 9-hole golf course, not an 18-hole golf course. So to be valid, the hole number has to be between 1 and that constant course.num of holes, right? And it has to be, so it'll be greater than or equal to 1 and less than or equal to the course.num of holes. So that's the first check you have to make sure that the hole is valid. Okay. The second check is it has to be in sequence. And if we go to our if we go to where do I want to go? It has to be in sequence, so it has to be the next one. And we know what hole has already been played, right? Because we have this right here, this dot holes played. So this tells us how many holes have been played, and it tells us our next empty element position, and it starts out at 0. So in our record scores, this hole number has to be equal to the holes played plus 1, right? If it's the first hole, it would be, we know that holes played is equal to 0 if it's the very first hole, so hole number has to be equal to holes played plus 1 in order for it to be in the proper sequence. So you want to make sure it's valid, that it falls, it's actually on the course, right? And that it's in sequence, that it's the hold plays plus 1. If all of that is true, then you're going to record the score. So you will then give it the whole number and the number of strokes and call your, well, I'm sorry, you already have the whole number and the number of strokes. You're going to call, what are we doing here? We're going to insert the score into the array and bump our number of holes played up by 1. Okay, so you're going to add it to the array in position, element position, holes played. Okay, and then you're going to bump it up by 1 and return true. Otherwise, you're just going to return false. You're not going to do anything else. Returning the number of holes played, just return the value of that instance variable, return the name of the player, return that. So I would start there and get that stuff to work first. Then I would come down to getting the score on a hole. So you're giving me the whole number. Did they actually do this for you? It's actually done. So they're giving you a whole number. So if it's greater than or equal to 1 and it's less than or equal to the holes played, then we know that the whole number is valid. And if so, we return the whole number minus 1. Because remember, hole 1 is in element position 0. Hole 2 is in element position 3, and so on. So we'll return the whole number minus 1. Otherwise, if it's not valid, we return invalid entry. Total strokes on the given holes. So first, check and see, is the whole number valid? Is it less than your holes played? Is it less than or equal to your holes played? Make sure it's a valid whole number, okay? And if it is, then you're going to have to loop through, adding up all of those holes scored up through that whole number, so up through your through num, and then return that value. Otherwise, if it's not a valid number, return invalid entry. Now this one's a little bit trickier, okay, the get par on the holes. So you're still going to need to make sure, you're still going to need to do the same work we did up here. Was it a valid, is it a valid hole? And then you're going to loop through, but you're going to have to get the par. So you're going to have to do that course.getHole.get par. .get par, so course.getHole.get par, passing in the whole number. And then adding, doing your par minus strokes to determine what your par is. And these two, I'm in the test case. No wonder this is screwing me up here. Category, again, is going to be a loop where you're checking for, are they at par or over par? So you're going to have to fill in this field here. I think this is about, I think I'm going to stop here because we're at 9:30. When is this due? The 25th. So it's due next Wednesday. Right? Just want to check and see how much we got going on this week as far as PowerPoint. "29 slides, which isn't a whole bunch. I'm going to try to finish the last few functions or methods on Lab 4 at the end of Thursday's session, guys. That should give you a pretty good starting spot, right? Getting all the test cases written and focus on those initial methods there, and then I'll finish up going over this at the end of Thursday's session. All right? So hopefully you've got a good grasp of the string bag class, which actually that gives you a good practice for dealing with arrays and dealing with that count variable, which will be similar to the holes played. And if you run any questions, you can always, or problems, you can post to Piazza or give me an email. All right. So have a great night, everyone, and we will see you Thursday.